Hopefully you can see this. What I'm basically trying to show here is what we're actually after. This is a standard AC phase, one cycle. What this is showing here is one cycle of a flywheel around a stator plate. This is done many times per minute, 1100, 1200, 8000 when you're revving, up to 8000 revs per minute. So you can imagine that going 8000 times per minute. This drawing here shows DC. So when you've rectified from AC to DC, you don't get the minus pulse. This is full wave rectification shown on a drawing. What it does is it flips between the plus VE, which is electrical output, to the minus VE. The diode basically flips. So when you've got half a cycle, then it turns around and that becomes the plus, and back again, and outputs twice the power. You won't get exactly twice the power because you're limited with what your rating of your rectifier is, and also there's losses with cable loss, lighting, your bulbs will put resistance in the circuit, switches, etc. So you'll never get double. If your flywheel's rated at say 80 watts, you'll never get 160 watts out the back. You'll get, depending on, I'd say around about 150 is a good achievable figure, normally about 140. Parts needed to achieve full rectification, depending on what you're updating at the moment. If it's a AC-DC system, in other words, if the lights are working straight off the stator plate, but you're still charging a battery, you've got half wave rectification and AC rectification. So your lights will be fed direct from the stator plate, and your battery will do a horn, backlight, parking lights, and little else basically in a standard setup. What you can actually achieve by changing from that type of system, which was standard on LI, TV, GP in the British market, is you're going to get better lighting. You can add USB chargers, etc. You can basically, the sky's the limit. Radios, satellite systems, you can put whatever you want and modify your system to become more usable in the current climate on the road. So you can fit LED lighting, etc. with no hassle. It's in my opinion well worth doing, especially if you've got an LI or you've got a system with already that's got battery fitted to it, because you've already got the battery. You'll have the DC horn, the switches will work as they are with little or no adjustment to anything. So the output from the stator plate will go in directly into the rectifier. The rectifier, when you've done a mod to the stator plate, will turn this cycle or one spin into just DC output. I will put a drawing in, diagram to try and explain a little bit more. It's not rocket science. If you look on it, the actual system is just using the full wave rather than you're regulating half a wave, which is what that beastie does. That's just a bog standard solid state rectifier. You can actually make that out of 4 diodes if you know how to wire it, save money. But that fits inside a regulator box quite easily, as fitted to a GS. In my case, my LI and my PX have both got full wave rectifiers, which are slightly bigger. They handle a lot more power, and also they require a little bit more wiring than this one does. This will fit in a standard GS with just changing the ends basically. So you've got push on connectors as opposed to screw terminals. You can still use the fuse in the rectifier. You just wire the output from the plus directly onto the fuse input. then the fuse goes through and the output goes to the battery. And then the system then feeds from battery for your parking lights, your horn, etc., as it would do in a standard bike. You're not changing any wiring at all. It's just the easiest upgrade available to remove 60-year-old technology, basically, for a solid state rectifier. The ones that are fitted to standard PXs, which Lambrettas use on their conversions, are either 3-pin, which is an AC to DC, or AC to AC out, and then you've got the 5-pin, which converts the AC half wave into the battery charging. So you've got a terminal just for the battery, and you've got a terminal which will feed your lights. Your lights are still direct current straight from the stator. When you change to full wave, everything is connected to the battery. All your switches, all your power drain comes from the battery. And in my case, I found it easier to change because mine was a full AC system on my PX. It's a very early EFL. It needed either rewiring old switches to make them change the way that they interact with the horn and lighting, or I just changed them for more modern ones because they'd already done that reworking, because the last of the PXs had the DC horns, etc., fitted to them anyway, and they'd also had the battery with the electric start, where mine's a kickstart, hasn't got electric start fitted to it. You don't have to do that if you don't want to. It just gives you better lighting, better power. When you sort of pull up at a set of lights, you'll